Welcome to a short introductory video for our digit management system. It will be followed by a set of short tutorial videos that will show step-by-step instructions of how to do specific things using this platform. Now, Didgets is a unique data management system that introduces a whole new way to manage all kinds of data: structured data, unstructured data, semi-structured data. And it is a platform that uses Didgets, which is short for data widgets, which are smart data objects with lots of interesting features. Here's a quick blueprint of a digit object in that it has a short fixed size metadata record that contains its unique ID, other attributes, its allocation information, things like that. Each digit has an optional data stream between 1 and several trillion bytes that can be stored within the digit. Each digit also has a set of optional tags, which are like key value pairs mapped to the digit that the tag is attached to. So if this was a photo, for example, the data stream would contain the actual maybe JPEG file data that would show you the picture. The metadata would tell you that this is a picture and where it is on the disk and all that fun stuff. And the tags might be what camera you took it with, who's in the photo, where the photo was taken, or what was happening in the photo. So tags are a great way to search for digits based off of the metadata. Now, digits can be either public or private, meaning private ones are the ones that you've created. Public are ones that somebody else created and you just happen to have a copy of it. That's really handy for things like backup and security and things like that. You may not be that concerned about protecting something you just downloaded off the internet. Um, Digits can also be managed or unmanaged. Unmanaged means that we treat the file system, a file data as a black box. We don't care what's in it really. But if this was a list or a key value store, we control the data that goes inside that data stream. So Digits is kind of like a digital erector set. If you notice erector sets, they're made up of lots of different pieces. But each erector set may only have a dozen or 2 dozen different kinds of things: wheels, pulleys, connectors, motors, things like that. Each piece does generally just one very specific thing, but you can put them together in all different kinds of combinations to create lots of different things. You can create dune buggies and tractors and cranes and diggers and bridges and things like that, just by putting together the pieces in a different configuration. Well, Digits is like a digital erector set in that we can create hierarchical file systems out of these things. We can create relational database tables, indexes, all kinds of things out of these very simple digits. Now, a pod is what we're calling our digit container. So in this particular instance here, we have 2 pods that I've created, one on my SSD and one on my hard drive, and filled it with some digits. Each digit is like a virtual disk within the native file system, and that we do all the block allocations and keep track of things, but the file system may control the actual disk accesses. What I'm showing you here is our digit browser, which is our administrative tool. We use this to demo the system. It's a useful tool to do a lot of things, but it's a very mouse-driven interface. So if you just hold your mouse button over an object, it'll often pop up information about that object, in this case the pod, where it's located, how big it is, things like that. If you hold it over just a part of the window, it might tell you what's happening in that window. So for example, go over on our databases tab. You'll see we have some definitions here, some connectors, some tables. If I hold my mouse over a table, it'll tell me what columns are in that table and what type each column is. Here's a connector to an external database. It'll tell you, how you're connecting in, what the username, etc. The definition again will tell you what columns have been defined for this, etc. If we go over, we can create indexes out of these. So, for example, I create a little script index. We can tell, words that were selected. So the word param was in a bunch of files, and it'll tell you where within those files all these different, or that particular word was found. We have sets, so we can like a file manager. So you're familiar with a file manager on your native operating system that lets you browse folders and find files and copy and paste and things like that. We can do the same thing with our file digits. And folder digits. So we can create folders, put files in them, and make it very easy to go find things. We can do very fast queries. So let's come over here and find, for example, all the scripts. So here's a particular JavaScript. I can double click on it. We'll show you the contents of the data stream. We will show you all the tags we attached when we imported this file into a digit, and here's some attributes in that metadata record. If we want to find all the scripts that have a web folder somewhere in their path, I can just click on that, and this will tell me the 3,627 JavaScripts in the system that have that folder. So we want to make it very fast to put hundreds of millions of these digits inside of a pod, tag everything with metadata records, and then find things based off them very quickly. Again, in other videos, we'll show you how to create database tables, create indexes, work with sets and other things and tags. But just want to give a good introduction of what our system is about, and let you know that this is designed for all kinds of data. Thank you very much.